Welcome. In this session, we are going to do another example of a word problem where we have to find absolute extrema over an infinite interval. This time, it's about finding maximum profit. We are given the demand equation in the form P equals an expression in Q and the cost function as a function of the quantity Q, and I have to find the output level at which the maximum profit occurs. So I have to first find the profit function. I will calculate that as revenue minus cost, and we will find the revenue function from the demand function in the fact that revenue equals unit price times quantity. So first R equals PQ. P is 540 divided by the cube root of Q. So R is 540 divided by Q to the power 1/3 times Q. Q divided by Q to the power 1/3 is Q to the power 2/3. So the revenue function simplifies to 540 Q to the power 2/3. Profit is revenue minus cost. So revenue is 540 Q to the power 2/3. Cost is 10,000 plus 18 Q. If we simplify this by distributing the minus in front of the parentheses, we get 540 Q to the power 2/3 minus 10,000 minus 18 Q. I have to find its absolute maximum. Since there is no other restriction on Q, Q can be any positive number. We'll find the critical values of the profit function first. Differentiating the profit function is easy because I just have to use the power rule. Its first derivative, dP over dQ, is 540 times 2/3 Q to the power 2/3 minus 1. 540 times 2/3 is 360. 2/3 minus 1 is negative 1/3. The second term is negative 10,000. Its derivative is 0. The third term is negative 18Q. Its derivative is negative 18. So to find the critical values, I'm going to set the derivative equal to 0. So 360Q to the power negative 1/3 minus 18 is 0. If I add 18 to both sides, I get 360Q to the power negative 1/3 equals 18. Let me write that using fractions. So we get 360 divided by Q to the power 1/3 equals 18. Cross multiply. 360 equals 18 Q to the power 1/3. Divide by 18. So 360 divided by 18 equals Q to the power 1/3. 360 over 18 is 20. So we get 20 equals Q to the power 1/3. Now cube both sides. That gives me 20 cube equals Q, or Q is 8,000. We will use the second derivative test to decide what kind of extremum this is. The second derivative of profit with respect to Q is the derivative of this expression, 360 Q to the power negative 1/3 minus 18. And that will be 360 times negative 1/3 Q to the power negative 1/3 minus 1. Negative 1/3 minus 1 is negative 4/3. So that's negative 120 Q to the power negative 4/3. So that's negative whenever Q is positive. So that means that by the second derivative test, 8,000 is a relative maximum. Since there is just one critical value and it's a relative maximum, the critical value is also the absolute maximum. So the absolute maximum occurs when Q is 8,000. So the output level that gives the maximum profit is 8,000 units. This concludes this example.